that we are sharing to the right person. So all of these questions we ask during like consulting, and we work very hard with the developers to make sure that they are all the issues that we found are addressed, and the implementation is bug-free, kind of bug-free, before we allow them to go to launch to the world. So. So let me share a little bit more about partnering. This is actually the main topic of this presentation, because I believe this is the only way for us to fix, to make sure that we have safe products. We need to make sure that it's impossible for people to introduce bugs in the first place. So we have a set of techniques that we do. We apply security engineering to APIs, frameworks, and platforms to eliminate, reduce, and mitigate entire class of security bugs. So basically, we want to make sure that if the code can combine, it must be bug-free. So combine time is the best time, to find bugs. And I'm going to share more about that. And the second thing that we do is we use false positive free static analysis to identify bug patterns and make sure that code having them cannot combine or are flagged, in code reviews, so that the reviewers can tell the person working on the code to fix them. And we use our build system allows us to restrict access to some APIs that we deem too dangerous for people to use. For example, OpenSSL is a crypto library. It's a great crypto library, but it provides very, very dangerous APIs. And we don't want people to use them directly. So if people want to use them, they have to get security approval. The only way for us to do that is to restrict the build system, so that if people want to link against the OpenSSL library, they have to get permission. They have to be added to a wireless, and we control the wireless. So this is the advantage of having a single repository, because we can ensure that anywhere in the repository, we know who is using what, and we can restrict people from using the APIs that we don't want them to use. We also run a very large education program where we write, documentation, run hacking, internal hacking, external hacking competition, host war games, do collabs, and we do all sort of things just to, get people engaged. And some people want to learn, some people really don't want to learn. Like developers, we are busy, right? We just want to do whatever it takes for the code to combine and run. And because of the pressure from the product manager, because the pressure from, all the people waiting for the features, or because of work-life balance, we can't really ask people to read all the documentation. So there must be a better way to do this. It must be better to, if people write the code and it combine, it should be bug-free. That's our goal. So the second thing that we do, like I said, we make it hard to exploit bugs. So in this slide, on the slide, you will see a lot of terms and keywords, and later on you can search for the keywords. And all of these projects are open source on GitHub or somewhere, and you can find all of this technology we provide for free. So for XSF, for example, cross-site scripting, which is the most popular program we have at Google. We have hundreds, maybe thousands of cross-site scripting every year. So anyone doesn't know what is a cross-site scripting vulnerability? It's basically allows people to, for example, you go to Gmail and you read an email from the attacker. The attacker can basically read all your email just by, because you read his email, he can read all your emails. It could be that bad. So And to mitigate the buffer overflow, we work on sandbox at the kernel level and the user level. We improve the compiler. For example, we add the control flow integrity to the GLAN and LLVM compiler. We develop a new user space heap allocator to make sure that it should be hard for people to exploit heap overflow. And we improve kernels by introducing read-only or executable only memory pages. Or we improve ASLR, which is a mechanism that allows us to load the kernel as a random address, so that it will be harder for someone to exploit buffer overflow in our kernel or in the user space program. We also develop custom security managers for Java and Go runtimes. Basically, for example, if you run a web server and your web server just accepts incoming requests and look up the database and shows a form, then it doesn't make any sense for the manager to make outbound network connection, right? So if the Java program make outbound network connection, then that's a sign that something is wrong. So, and then the security manager is like a lightweight sandbox that allows us to detect all of those asset violations. And then this is response remediation. Basically, we first everything. Like we run a very large fuzzing program, and we pay researcher. We allow people researcher to use our fuzzing cluster to fuzz anything they want for free. And we has anybody heard of Project Zero? I think it's a pretty cool program where we build a very, very large team of very well-known researchers, vulnerability researchers, and their goal is just to make the internet safer. And they go and find bugs and kill bugs in anything that they found interesting, like Windows, Apple, Google products, Internet Explorer, Flash players, anything that antivirus, anything that they found interesting, anything that could improve the security of Google and the internet as a whole. We also continuously monitor and update third-party code. So we have a program, I think it's open source, but I couldn't find it in GitHub. It's called Vomit, Vulnerability Management something. And we basically subscribe to the vulnerability feed. And whenever we saw a news announcement of a new vulnerability, we look at our internal collections of third-party libraries, and we see if we're vulnerable to that version, and then we urge the owner of the library to upgrade it, and then ship the upgrade to everyone using over-the-air updates. So over-the-air updates is very important if you run like cloud-based software, because regardless of what we do, we learn that we would have bugs anyway. So it's very important for us to be able to fix those bugs in a timely manner. The only way to do that is to be able to push updates to cloud software as fast as possible. We run a very successful vulnerability rewards programs. Every year we pay like multi-millions of dollars to anyone who found a bug in our products or want to spend time finding bugs in our products. Like if you just, of course, you have to show us some, we have to get to know you first. And we actually give people research grant so that people can, spend time finding bugs at their own pace. And if they found something, they get another reward. If they don't find anything, they still keep the money. We also pay people money if they improve the security of critical open source project that we depend on. For example, OpenSSL, OpenSSH, all of those packages are very important for the security of the internet. So if you send a patch to improve it, to add new important feature, to fix something, we want to help you. We want to give you some money. And one of our last product, like the 4 products that I show you here, have their own like vulnerability reward programs. Like Chrome, every year I think Chrome paid like up to $10 million for people who find bugs in Chrome. Android, Google Play, and the whole we will have like one single program as well. So yeah, like $5, and then you would get some reward. Okay. But regardless of what we do, we still have lots of bugs. Like we were scratching our head, like why we still have lots of bugs? Like despite all of these things. We found out, for instance, like I said, we have process scripting. It's just something that we can solve. Like we have like maybe more than 100 instances of process scripting every year. And the traditional approach of educating developers, testing, and reviewing doesn't work at all. So the more we look at the problem, the more we feel like the problem is in the underlying APIs. So developers are using APIs that have basically very sharp edges and with subtle security pitfalls that have to constantly keep in mind. If you are writing any code in C using the C string APIs, you for sure have overflows unless you maybe that was in. If you are writing code using any SQL API, SQL API, then you would have SQL injection for sure. And if you're using the web platforms, then there are lots of problems that we have to care about. Process request functionality, process